Hello everyone and welcome to Pep Coding. I hope you all are extremely good. So today in this video we are going to discuss the solution of n queen problem using bits, right? So we are given a number n and we have a board of n cross n size and we have to place n queens on that board in such a way that no two queens can kill each other, right? So for example, we are given the value of n as 4, so we are having a board of 4 cross 4, right? So let's draw the board. So there are 4 rows and 4 columns. Right? So we have to place 4 queens in this board in such a way that no two queens can kill each other. Now if I place a queen here, now other queen can be placed in this column, can't be placed in this row, can't be placed in this diagonal, can't be placed in this reverse diagonals, right? So if any of the queen is placed in any of these 8 directions, then that queen will be killed by this queen, right? So we have to place the queens in such a way that no two queens can kill each other. That is, no any queen can place in any of these 8 directions, right? So we have to check for the row, for the column, for the diagonal, and for the reverse diagonal, right? So we are having 4 constraints in this problem. If I place a queen here, then if I want to place a queen in any of the cell, then I have to check in a particular row, in that particular column, in that particular diagonal, and in that particular reverse diagonal. If any of the queen is placed in any of these directions, then I can't place my queen in this particular cell, right? So this is the problem. Now we have to check 4 conditions, that is for row, for column, for diagonal, and for reverse diagonal, right? For reverse diagonal. But for row, now we are having a board of n cross n size and we are having n queens. Two queens can't be placed in one row. This means that one queen can be placed, only one queen can be placed in one row, right? So if for this we can use that if we place a queen in a particular row, then we can't place any other queen in this row, so we can move in the next row, right? So after placing a queen in a particular row, we have to move to the next row. So in this way we are placing one queen in one row only, right? So we don't need to check the condition for row. We are only doing what, that when after placing a queen in a row, we are moving to the next row, right? So in this way the condition for but a queen to be placed in a each row is satisfied, right? So we don't need to check the condition for the rows. Next is for the column. So if we place a queen in a particular column, we have to check in that column only, right? So we are using an approach of arrays, right? So we are having an array of n size. So if while placing a queen here, we are marking this cell, this index as true. Now this true means that I can't place any other queen in this particular column. Similarly, if I place a queen in this column, I'll mark this cell, this index as true. This means that this is the column array. This means that I can't place any other queen in this particular column, right? So while placing a queen in this column, I will check in the array that if this value is true, this means that I can't place my queen here, right? So similarly, the condition is for diagonal and for reverse diagonal, right? So we are using arrays, right? So let's use it for diagonal and reverse diagonal, right? For column, for diagonal, and for reverse diagonal, right? So the size of the column array is n, that is 4. The size of the diagonal, now the number of diagonals in this particular board is, let's find the number of diagonals. Right, diagonals and anti-diagonals. Now the diagonals. Now we need something to identify a particular diagonal. For example, we need to identify that this particular cell belongs to this diagonal, this particular cells belong to this diagonal, right? So we can use what, that we can find some values such that we can identify the particular diagonal. So we can use the row and the column value. Here the row plus column. Let's find out the row plus column value of each cell. So here it is 0, here it is 1, 2, 3, here it is 1 plus 0, 1, here it is 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 4, 2 plus 0, 2, 2 plus 1, 3, 2 plus 2, 4, 2 plus 3, 5, 3 plus 0, 3, 4, 5 and 6. So in this way we can identify that the particular diagonal. So this is the first diagonal, second diagonal, third diagonal, fourth, fifth, sixth and seventh. So total there are seven diagonals in this particular board, right? So 7 we can represent 7 as 2n minus 1, that is 2 into 4 minus 1, that is 8 minus 1, 7, right? So the number of diagonals in a particular n cross n board is 2n minus 1, right? So we can find the particular cell, that whether a particular cell belongs to which diagonal by using the row plus column value, right? So if I place a queen here, now I want to place a queen, so I'll mark the diagonal value in the diagonal column number 3, okay, right, 0 1 2 3. So I'll mark 3 as true. Now if I want to place the queen in this cell, I will check the third index in the diagonal array, right? Now the third index is 2. This means that a queen is already placed in this diagonal, so I can't place my queen here, right? So for diagonals we are using r plus c value, and the size of the array is 2n minus 1. Now the for anti-diagonals, reverse diagonals, right? So for reverse diagonals we can use r minus c, that is row minus column value, right? So if I found the row minus column value of each cell, then let's find out 0 minus 0, 0, 0 minus 1 minus 1, 0 minus 2 minus 2, 0 minus 3 minus 3. Now this is a particular diagonal, 1 minus 2 minus 1, 2 minus 3 minus 1. Now I am getting the correct value to identify a particular reverse diagonal, but the values are of negative values, right? But in the array we can't use negative indices, right? So we have to convert this into positive. So we are going to use what? We are going to use row minus column, plus we are adding some other component to make it positive, right? So we can add the size of this board, that is n minus 1, right? Now the size in this case is 4, 4 minus 1. So we are adding 3 to row minus column value, right? So let's find out 0 minus 0, 0 minus 0 is 0, plus 3 is 3. Now 0 minus 1 is minus 1, plus 3 is 2. 0 minus 2 is minus 2, plus 3 is 1. 3 minus 0 minus 3 is minus 3, plus 3 is 0, right? So in the same way we can find the values for all other cells. So 1 minus 3 is minus 2, plus 3 1, right? Similarly for this diagonal, so for this diagonal, for this and this, the number of diagonals are same, that is 2n minus 1. Now these all are the reverse diagonals present in our board. We can identify whether a particular cell belongs to which diagonal by using this value, that is r minus c plus the size of the board minus 1, right? So we will use an array of 2n minus 1 size. So if I place the queen here, so I'll mark the, in the reverse diagonal I'll mark the value as true. Now if I'm going to place a queen here, so I will found the reverse diagonal value of this cell and check that if the value placed at that particular cell is true or false. Since the value is true, so I can't place the queen here. Why? Because the queen is already placed in the reverse diagonal of this particular cell, right? So in this way we can find the diagonal and the anti-diagonal values, right? So let's solve. So this is the column, this is the diagonal, 1 2 3 4 5 6. This is the and a reverse diagonal, 3 4 5 6, right? 0 1 2 3 0 1 2 3 4 5 6 0 1 2 3 4 5 6, right? So first of all the values are false, false, right? Now let's place the queen in the first, let's place our first queen. If I place the queen here, now I will check in the column, in the diagonal and in the anti-diagonal. Now the column value for this is 0. The value placed in the column array is false. So I can place the queen in this column. Now the diagonal value for this is r plus c, right? So 0 plus 0 is 0. Now the value present in the diagonal array is false. So I can place the queen in this diagonal. So this is r minus c plus 3, right? So 0 minus 0 is 0 plus 3. So the value is 3 is false. So it is safe to place the queen in this cell, right? So after placing this, we will mark this as true, right? This is 0 plus 0, mark this as true. This is 0 plus 3, mark this as true, right? Next, after placing the queen, move to the second row. Now we will check in this column. Now the value at 0th column in the column array is true. So true indicates that we can't place it in this cell, right, in this column. Next we will check in this column. The value at 1 is false, so I can place in this column. Now I will check for the diagonal, right? Now the value for the diagonal is 1 plus r plus c, that is 1 plus 1 2. The value is true, right? So I can place the queen in this cell according to the diagonals. Now we will check for the anti-diagonals. The anti-diagonals, the value is 1 minus 1 0 plus 3, that is 3. Now at third position the value is true for the reverse diagonal. So we can't place the queen in this particular cell, right? So we will check in the next column. So next we will check in this column. According to the column array, we can place in this. According to the diagonal array, the value is 2 plus 1 3, so we can place in this. According to the reverse diagonal also we can place, since the value is 1 minus 2 minus 1 plus 3, that is 2. At 2 the value is false, so we can place in this particular cell. So we will place the queen here. Next we will move to the next row. Now we can't place it in this cell, we can't place in this cell according to the diagonal array, right? Can't place in this according to the column, can't place in this according to the reverse diagonal, right? So we will backtrack from this, we will place our queen here, right? So next we will mark this as true. So all these arrays are going to be updated, right? So next for the next queen we can't place it here, we can place here. Next we can't place here, we can't place here, we can't place here, we can't place here, right? So we will backtrack. When we will backtrack, set this value again to false, right? So next we can't place the third queen here, we can't place it here, so we will backtrack. Now again we will backtrack. Now place the first queen here, mark this as true, right? So place here 0 plus 1, mark 1 as true, all others are false. Now 0 minus 1 plus 3, mark 2 as true, all other are false now, right? Now move to the next row. We can't place here according to the diagonal, we can't place here according to the column array, we can't place here according to the reverse diagonal, we can place the third queen here. Next we can place the third queen here, this is the second queen, we can place the third queen here. Next we can't place the fourth queen here, we can't place it here, but we can place it here. So this is a possible answer. Now the format for printing the answer is this, that is row column, right? So we will print the row and column for each queen. Row is 0, column is 1. Row is 1, column is 3. Row is 2, column is 0. Row is 3, column is 2, right? So this is a possible answer. Now there can be more possible answers, so we have to find all the possible answers. So we will do what? We will backtrack. Now the fourth queen will be placed here, but it is not safe to place, so again we will backtrack, unplace these queens and backtrack, right? So this is the way how we are using the arrays in order to find that whether it is safe to place a particular queen in a particular cell. But again we are using an extra space. right? So in the backtracking, the brute force for solution is what, that if I am going to place a queen in this particular cell, I will check in all this row, I will traverse all this column, I will traverse entire diagonal, and I have to traverse the entire reverse diagonal. But this is a very complex solution, so the array is much less complex than this, but this is using a three arrays, right? So this approach is using the extra space. Now we can do this without using the extra space. So instead of array, we are using the bits, right? So we can use bits here, right? So we will use the bits. We will use an integer for columns, for diagonals, and for anti-diagonal, for reverse diagonals, okay, right? So we will initially, all these are 0. So all the bits are 0 initially. Next we will do what? So we will update, instead of array, we will update the value for each bit, right? So these are the bits for column. These are the bits for 0 plus 1, 1, 1 plus 0, 1. So these are the bits for diagonals. These are for the reverse diagonals. Right? So this is our 0th column, first column, second column, third column. So initially all the bits are 0. Right? So initially all the bits are 0. This is our 0th diagonal, so 0. All the bits are 0. This is 0, first diagonal, second diagonal, third, fourth, fifth, and sixth. Again, this is 0th diagonal, first diagonal, second, third, fourth, fifth, sixth. Right? So initially all the bits are set to 0. Now if I want to place a queen, my queen here, now I will check the bit, the 0th bit in the column calls integer, that if it is 0 or not. Now this bit is 0, which means that I can place the queen in this particular column. Now I will check for the diagonal value. So for this cell I will find the r plus c value. The r plus c value is 0. Then I will check the 0th bit of diagonal integer. If the bit is 0, this means that I can place the queen in this particular diagonal. Again I will check for reverse diagonal. I will find the r plus c minus 3 r minus c plus 3 value for this particular cell. If the 0th bit is in the reverse diagonal integer is 0, this means that I can place the my queen in this particular reverse diagonal, right? So I will place my queen here. I will mark these bits as 1. Now there are only two bits, that is 0 and 1. So I will toggle the bits, right? Again I will check for the next queen. The bit corresponding to this column is 1. So I can't place the queen, my queen here, right? Similarly, I will check for diagonals and reverse diagonals. If I want to place my queen here, I will check the second bit of the call integer. This is 0, I can place it. Right, I want to place it here. I will find the r plus c value of this. I will check the fourth bit of my diagonal integer. If this is 0, I can place. Similarly, the r minus c plus 3 value of this, the value is 3. So I will check the third bit of my r divisional integer. So this is 0. This means that I can place my queen here. So I will place my queen here and set these bits to 1, right? So set these bits to 1, right? So instead of using the entire array, I am using only the 3 integers and using the bits of these integers, right? So let's try to execute. If you haven't watched the video of the implementing this solution using backtracking, watch that video first, then you will easily understand this solution. So firstly I have to move in each column, right? So let's use a for loop for moving in each column. right? So if the queen is safe to place, then place that queen, that is set the value as true, right? We will figure out the condition for checking that if the queen is safe or not. So set this is as true. This means that we have placed our queen in that particular cell, right? Next, find the solution for the next queen, right? So board will remain same, row will be incremented by 1. Why? Because after placing a queen in a particular row, we are moving to the next row, right? So rest all the integers are same. Now in the answer we have to add the row, next hyphen is there, convert the integer value to string. Next add a hyphen, right? Next the column, next a comma is there and some space, right? Next, after finding the solution for all the queens, backtrack in order to find all other possible solutions, right? So set this value again to false, that is we are unplacing our queen, right? Now we have to do this until we have placed all our queens, that right? So if I am at this row, this means that I have placed all my queens, right? So if the value of row is now 4, this means that I have placed all my queens, right? This means that if the value of row is now, right? So in that case, print my solution. Dot is there at the end of each solution, and a new line, right? And return from this, right? Now in order to check that a particular column is safe, in the calls initially all these values are set to 0, right? So this is our call, right? So in the call integer, in the calls integer, we have to move to the called bit, right? So we are moving to this bit and checking that if this value is 0. Similarly, in the diagonal integer, we have to move to the, for example, I want to check here. So firstly find the value of r plus c and move to that bit, right? So move to the r plus cth bit in the end diagonal and check that if it is 0. Similarly, move to this bit of the reverse diagonal integer and check that if it is 0, right? So in the calls, so this way we will check that if the bit is 0. So right shift the call integer by the call value and check that if this bit is 0. So if it is 0, this means that the column is safe to place, right? One more parenthesis. Always use parenthesis by using the bit operation, right? Next, check the diagonal, right? So move to the diagonal integer, to the r plus c, that is row, right shift it by row plus column value, right? And check that if it is 0. If this is 0, this means that the column is safe, diagonal is safe to place, right? This is n diagonal, right? The integer is named as n diagonal. Next, check the reverse diagonal, right? So in order to find the reverse diagonal, the value is row minus column plus the size of the board minus 1, right? So reverse diagonal and right shift it by row minus column plus size of the board minus 1, right? So if this is also 0, right? So if all these bits are 0, this means that column is also safe, diagonal is also safe, reverse diagonal is also safe. Then in that case, place the queen and set all these bits as 1, right? So toggle all these bits. So we can use the XOR operation for toggling the bits, right? So toggle these bits, right? So this will convert the bits to 1. Row plus column, right? Next is toggle the reverse diagonal bit. That is row plus column, row minus column plus size of the board minus 1, right? So this will convert all the bits to 0. And in after this finding the solution, we have to backtrack also, right? So we have to convert all these bits again to 1. So toggling will convert all the ones bit to zeros, right? So this is the uh, code for finding that whether it is safe to place a particular queen in a particular cell by using the bits, right? So let's execute this. Let's try to run this. We are having an error at line number 7. At line number 7, oh, here it is a double inverted comma and here it is board, right? So let's again try to run this. So we are getting the correct answer, right? Let's try to submit it. So our code is passing all the test cases, right? So what we are doing, right? So instead of using the arrays, we are using 3 integers, that is the column, the diagonal and the reverse diagonal, right? Initially all the integers are 0, which means that all the bits of these integers are initially set to zeros, right? So all these bits are 0 initially, right? Next we are moving in the column. So we are moving in the column. In the column we are checking in each cell, right? So in a particular cell we are checking the particular bit for the column integer, for the diagonal integer and the reverse diagonal integer. So we are checking the call bit for column integer, r plus cth bit for diagonal integer, and r minus c plus length of the board minus 1 bit for reverse diagonal integer. So if this all these bits are 0, right? So all these bits have to be 0. This means that our queen is safe to play. So we are placing the queen in that particular cell and we are toggling the bits, that is we are changing all the 0 bits to 1, which means that now we can't place any other queen in this region, right? So we are toggling these bits to 1, and after finding the solution we are backtracking, that is we are unplacing our queen and again we are toggling the bits, that is all this 1, the bits which are converted to 1, now all these bits are again converted to 0, right? That is now we can again place the queen in that particular row, column, and in that particular column, diagonal and anti-diagonal. So we are not using any extra space and the complexity of this is also very low, right? So we are using the concept of bits for implementing the n queen problem, right? So if you haven't watched the n queen problem in backtracking module, so watch that first, then this problem will be very easy for you to understand by using bits, right? So I hope you understand that how to solve the n queen problem by using bits. So if you like the video, then give a like to this video, and thank you for watching.